By flight regime, launch vehicles can be classified. Number 1. Suborbital Launch System. A suborbital spaceflight, the spacecraft reaches space, but its trajectory intersects the atmosphere. That is, it falls back to Earth after reaching space at some point. Some examples are missiles, tourist flights, and sounding rockets. Number 2. Orbital. An orbital flight is a space flight in which a spacecraft is placed on a trajectory where it could remain in space for at least one orbit around the Earth. To remain in orbit at this altitude requires an orbital speed of 7.8 km per second. Orbital spaceflight from Earth has only been achieved by launch vehicles that use rocket engines for propulsion. Example, Sputnik 1 was the first human-made object to achieve orbital spaceflight. Number 3. Translunar. A translunar flight is specifically used for a flight to Moon using a special method of injection, which is achieved using a translunar space flight. Here an orbital velocity of 11 km per second is not required. But it need to provide a trajectory that will cause it to arrive at the Moon at the closest point from Earth. Number 4. Interplanetary. An interplanetary spacecraft spends most of its flight time moving under the gravitational influence of Sun. Interplanetary flights are commonly launched with the vehicle's final stage into a temporary parking orbit, to allow spacecraft checkout, and more precise control of the final injection maneuver, rather than being launched directly to terminal velocity. Then with the gravitational assist of bodies such as Moon, Sun, or planets, the flight is slingshot into a path to reach the planet with a very high velocity. A speed of 11 km per second is achieved by Voyager 1 with the gravitational assist trajectories at Jupiter and then Saturn.